A very cool concept is shooting a charged particle into a magnetic field. The actual shooting of the charged particle, we talked about it when we talked about parallel plates, but that follows conservation of energy. The electric potential energy gets converted into kinetic. If we're talking about shooting something in a parallel plate, the electric potential energy is the value of the charge multiplied by the volts, the electric potential, and that gets converted to kinetic energy. Kinetic energy is always 1/2 mv squared. If we know the Q and the volts, we can figure out the speed. Once the charged particles enter a magnetic field, there's a force exerted on it. We learned the left-hand, right-hand rule to describe the direction. The force causes it to bend in a circle, so that goes way back to what we were talking about at the start of the semester. But the force, in this case, if it's a moving particle, the QVB, sine the angle between the B and the V, makes it bend in a circle, so that's centripetal motion, mv squared over r. We can clean that one up a little bit because there's a v on both sides. We can say qb sine of the angle equals mv over r. If we practice that, here's kind of a classic type of question. It says it's a proton accelerated by 1,000 volts. Right off the bat I would pause. Because we know it's a proton, we know the charge. You can Google or look it up, positive 1.6 times 10 to the negative 19 coulombs. Because it's a proton, we also know its mass. The mass of a proton, again, look it up, 1.67 times 10 to the negative 27 kilograms. The proton's accelerated by 1,000 volts. It's moving to the right and enters a magnetic field that is pointed away from you. So we've got this proton. The 1,000 volts get it moving. We'll have to figure out how fast. It enters a magnetic field that's pointing away from you. To represent magnetic fields pointing away, we'll draw that with x's. So we've got a field of x's over here. Oops. Alright, once the proton gets in there, you can do the right-hand rule. Right hand because it's a positive. Point your right thumb to the right. The many fingers representing the magnetic field lines have to point away from you. When you do that, you get a force on the particle that's upward. You can double check that with your right-hand rule. What that means is when the particle gets into this field, it's going to follow a nice circular path, bending upward. The way this question is set up, I've chosen to tell you the radius. From the radius, you can figure out the size of the B field. I'm going to have to flip screens, so numbers we'll need to remember when we move on. It's a proton, so we know the mass, we know the charge. It's accelerated by 1,000, and eventually it follows a circle with a radius of 1 centimeter. Alright, now we can do some equation work to figure this out. To accelerate the electron, we talked about this before, the electric potential energy gets converted to kinetic energy, or the Q times volts equals 1/2 mv squared. Because it's a proton, we know it's Q, 1.6 times 10 to the negative 19. The question made up a voltage of 1,000. Equals 1/2. The mass of a proton is that 1.67 number. And I've run out of room. That's multiplied by v squared. Now that's a little bit messy, but you do some algebra and flip-flop things around. When we get to v, after rounding it off, it's approximately 4.38 times 10 to the 5. We now know the proton enters that field with a speed of that, 4.38 times 10 to the 5 meters per second. When a field, it starts to follow a circle that turns into an F equals ma situation. The force on it is QVB. I'm going to skip the sign part. The direction of the field was away from you. The proton was moving to the right. The angle between away from you and to the right is 90. The sine of 90 is 1, so that term doesn't really matter. We're looking for B in this case. We showed it before, but one of the V's is going to cancel out, so B is going to be mv over QR. We know all these numbers now. The proton has a mass of 167 times 10 to the negative 27. The V is that number we just figured out, the 438 times 10 to the 5. Oops, I made a mistake down here. The square disappeared to get rid of that square. And all of that is divided by the Q value, 1.6 times 10 to the negative 19. And the R that was made up in the question was 1 centimeter. We need to put that in meters, so that's 0.1 meters. I'll let you double check, but when we do the math, this one works out kind of nice, just under 0.5 or 0.46 Tesla. Flip through that one. That's a great concept. Physics teachers love this kind of question. You have to understand energy and voltage to get the speed, and how voltage connects to force and how speed connects to force and centripetal motion and radius.